guys, welcome back to my YouTube channel. Today we are going to discuss one more important problem related to linked list. So in this problem you have a linked list where each node contains an additional random pointer, and this random pointer can point to any node in the list including itself, or it can be null. So in other words, each node has a next pointer. Okay, so each node has a next pointer pointing to the next node in the list, that is a standard in a linked list, and a random pointer pointing to a node in the list which can be any node, or null. So here for this you can see a random is pointing to the null, and in this case random is pointing to 7. Okay, so our task is to create a deep copy of this linked list. Okay, so what is deep copy? So a deep copy means that you need to create a new linked list that is entirely separate from the original one, with the new nodes that have the same values as the original nodes. Importantly, the next and the random pointers of the new nodes should point to new nodes in the copied list that mimic the relationships in the original list. So so here, for example, if there are two nodes x and y in the original list where x dot random points to y, then for the corresponding two nodes x and y in the copied list, x dot random should point to the y. So this is the new node. Okay, so we have to return the head of the copied linked list. So in the input output format you can see a linked list is represented in the input output as a list of n nodes. Each node is represented as a pair of value and a random index, where val is an integer representing the node dot value, and the random underscore index is the index of the node that the random pointer points to, or null if it does not point to any node. So here you can see this input format. Okay, so our code will only be given the head of the original linked list. Okay, so now let's get started. Okay. Okay, so let's understand first what we are going to do in our code. Okay, so we are going to use hash map. So the main purpose of creating a hash map in this code is to establish a mapping between the original nodes, okay, and their corresponding new nodes. Okay, so for this purpose we are going to use hash map, and this mapping is essential for two reasons. One is creating a new nodes. Okay, so in the first pass of code, the hash map is used to create new nodes, okay, for each original node and associate them with their corresponding original nodes. So this allows you to ensure that the new nodes have the same values as the original nodes while maintaining a connection between them. Okay, and second step is updating pointers. So in the second pass of the code, the hash map is used to update the next and random pointers of the new nodes. So by looking up the original nodes in the hash map, you can find their corresponding new nodes and correctly set the pointers in the copied list to mirror the relationships in the original list. Okay, so in summary, the hash map serves as a critical data structure for efficiently creating a deep copy of the linked list while preserving the structure and relationships of the original list. Okay, so now let's write the code. Okay, so here first write map node original to new is equal to new hash map. Okay, so here This line of code initializes a Java hash map named original to new, okay, so that is used to store the mapping between the original nodes and their corresponding new nodes, okay, during the process of copying a linked list with random pointers, okay. So here map node comma node, okay, so this declares a variable original to new of type map node comma node. So this means it is a map where both the key and the value are of type node. So in other words, it is a map that will associate original node mean keys with their corresponding new nodes mean values, okay. And here new hash map. So this part of the line initializes a new instance of hash map. A hash map is a type of map in Java that stores key value pairs in a way that allows for efficient retrieval based on the key, okay. So putting it all together, this line is creating an empty hash map named original to new, which will be used to keep track of the mapping between the original nodes and their corresponding new nodes as the code iterates through the original linked list and creates a deep copy of it. So this mapping is crucial in the second pass of the algorithm when it comes to updating the next and random pointers of the new nodes based on their relationship with the original nodes, okay. So after that write node current is equal to head, okay. So here this line initialized a node named current with the head of the original linked list, okay, with the head of original linked list, and current is used as a pointer to traverse the original linked list, okay. So we are starting with the head node, which allows us to begin the traversal from the beginning of the list, okay. So after that write while loop while current is not equal to null, okay. So here this initiates a while loop that will continue as long as the current pointer is not null, okay. So it will keep iterating until we have reached the end of the original linked list, okay. So in the while loop write original to new dot put current comma new node current dot value, okay. So here in this line we are adding a mapping between the original node and its corresponding new node, okay. So a fresh instance of the node with the same value, okay. So here in original to new, so this is a hash map that will be used to store the mapping between the original and their corresponding new nodes, okay. So the key in the map will be the original node and the value will be the corresponding new node, okay. So current, this is a pointer that refers to the current node in the original linked list that we are iterating through, okay. So in the first pass we are creating a new nodes for each original node. So so for each current node we want to create a new node in the copied list, okay. And here a new node current dot value, so this part just creates a new instance of the node class and initializes it with the value of the current node. So this new node will have the same value as the current node but won't have its next or random pointer set yet, okay. So this new node will have the same value as the current node but won't have its next and random pointers set yet. Okay, so this original to new dot put, so this is a method call to add a new entry to the original to new map. So this put method take two argument, that is one is key, the original node current, that is our key, and the value which is the new node created. Okay, so putting it all together, this line of code creates a new instance of node with the same value as the current node and establishes a mapping in the original to new map associating the current node with its corresponding new node. Okay, so this mapping we will use later in the second pass to update the next and the random pointers of the new node based on the information stored in the map. Okay, so after that just write current update current. Okay, current is equal to current dot next. Okay, so after creating the new node and mapping it to the original node in the original to new map, the current pointer is updated to point to the next node in the original list. Okay, so this step is crucial because it allows the loop to progress through the original linked list. Okay, so now this is our first part. Okay, and now we are going to write the second pass of the code. So here let me write, this is our first pass, and in first pass we are just creating a new nodes, and store them in a hash map. Okay, so now we have first map. Now we are going to write a second pass. So what we are going to do in second pass, we have already copied the value, so we are going to update next and random pointers of new node. Okay, so now in the second pass we are going to update next and random pointers of the new node. Okay, so now write like this, current is equal to head. So here I write current is equal to head. So this line is going to reset the current pointer to the head of the original linked list, so it prepares to traverse the original list again starting from the beginning. So okay, so after that write while loop, again while loop, current is not equal to null. Okay, so again we are going to initiate a while loop that will continue as long as the current pointer is not null. It will keep iterating until we have reached the end of the original list. Now in the while loop write node new node is equal to original to new dot get current. Okay, here, so within the loop this line retrieves the corresponding new node for the current node from the original to new map. So you remember that in the first pass we created the new nodes and mapped them to their corresponding nodes. Okay, so here now after that we are going to write new node dot next is equal to original to new dot get current dot next. Okay, so this line updates the next pointer of the new node. It does so by looking up the current dot next node in the original to new map to find its corresponding new node and assigns it as a next node of new node. Okay, so this step ensures that the next pointers in the copied list are correctly set to represent the same relationship as in the original list. Okay, so here in the example, like if original node 1, we have created new node 1. So if original node 1 has this next is set 13, so new node 1 dot next is also set to 13. Okay, so this is what we are doing here. So after that new we have write next. Now write random new node dot random is equal to original to new dot get current dot random. Okay, so here similar to the previous line, this line updates the random pointer of the new node. So this line is going to update the random pointer of the new node. So it looks up the current dot random in the it is going to look the current dot random node in the original to new map to find its corresponding new node and assigns it as the random node of the new node. So this step again ensures that the random pointer in the copied list are correctly set to represent the same relationship as in the original list. So and in the end we are just going to write current is equal to current dot next. Okay, so after updating the next and random pointer for the new node, we move the current pointer to the next node in the original list. And okay, so here we write it like this, and in the end we are going to return original to new dot get head. Okay, so we are going to return original to new dot get head. Okay, so let's try to run our program and see if it's working fine or not. So all the test cases are passed. Let me submit it. Okay, so our solution is accepted with just 0 milliseconds runtime, and it beats 100% of users with Java. So I hope that you are able to understand this problem. So if you like this video, then please share and subscribe. Until then, bye bye and keep coding. Okay, thanks.